Hi, thanks for joining us again. We're going to do a quick instructional video on a data sufficiency problem. If x is not 0, is the absolute value of x less than 1? So the first thing we want to do is rephrase this question. So x does not equal 0, and we want to know, is the absolute value of x less than 1? Well, if x does not equal 0 and the absolute value of x is less than 1, these two things combine to tell me that x is between -1 and 1, right? Where x is not 0, that means that whether negative or positive, the real question that I'm being asked is whether or not x is equal to a fraction. So if I can prove or disprove this statement, then that is sufficient to answer the question, and that is all that I need to determine from this data sufficiency problem. Now, I personally think that statement number 2 is a little less complicated than statement number 1. So we'll go over statement number 2 first, and we will use the BD ACE chart in order to evaluate this question quickly. So we know that x does not equal 0, right? So that tells us that x is either positive or negative, right? So what does that tell us for the absolute value of x? Well, if x is positive, then the absolute value of x is positive. And if x is negative, the absolute value of x is also positive, right? So for which of these two cases can we say anything conclusive through, or what is the absolute value of x being greater than x? When is that true for either of these cases? Would it be possible if we know, let's say x is equal to positive 7? If x is equal to 7, the absolute value of 7 is 7. Is it true that 7 is greater than 7? No, 7 is equal to 7, so 7 is not greater than 7. So by the virtue of the fact that the absolute value of x is greater than x, we know that this case is not possible. Right? So that tells us that the only possible case we have is where the x is negative, such that the statement, the absolute value of x is greater than x. So what we really gain from this one statement is that x is negative. Okay. So statement 2 alone is not sufficient. So I know that my answer choice is not B or D. So now I need to evaluate answer choice, well, statement 1 to determine whether it's answer choice A, C, or E. So if x divided by the absolute value of x is less than x, what does that tell us? Well, let's do a little bit of algebra here. So let's say this is equivalent to say that x is less than x times the absolute value of x. Okay. Now remember, we can't use any of the information gained in statement 2 yet until we move on to evaluate answer choices C and E. We need to evaluate statement 1 on its own first. So if we don't know anything from statement number 2, what can we garner from this arrangement? We can make this move from the absolute value of x in the denominator of this fraction and multiply both sides by the absolute value of x, because we know the absolute value of x is always positive. Therefore, we don't have to worry about the potential changing of this sign right here. Okay. So again, let's consider the case that x is either positive or negative. Right? So what does that tell us about x times the absolute value of x? Right? All right. Well, x times the absolute value of x, right? If x is positive, would just give us x squared, right? If x is negative, we would in fact have negative x squared. Well, maybe not necessarily that is the case. No, that's actually true. Even if x is negative, we would have a negative x squared, right, for x times the absolute value of x, right? So now, we know that this statement is true, right? So what does that lead us to believe with regards to x being a fraction, whether or not x is a fraction, right? Well, if x is positive, then what we've really got is we've got x is less than x squared, right? So we know that x, a positive number, is less than this x squared, also a positive number, meaning that x must be greater than 1, right? Because unless x is a fraction, right, x squared will always be bigger than x. Right? Even if we have 1.1, 1.1 squared is 1.21, which is bigger than 1.1, right? So this really tells us, and you can see that by dividing x on both sides, that we would get that 1 is less than x or x is greater than 1, right? But what about in this case, in the negative case? In the negative case, we have this negative number x, and we know that is less than negative x squared. Well, even if x is negative, if we square it, it'll become positive, but we've got a negative times x squared. Right? So we have a negative number that is less than this squared negative number. So what does that look like on a number line? Well, we know that we're to the left of 0, right? And we know that this x value is less than, right, to the left of this negative x squared value. So when is this possible? This is only possible, right, when both of these numbers are inside of a 1, or in between 0 and 1, right? Let's go with an example, right? So let's say x is equal to negative 3/4, right? So if x is equal to negative 3/4, the negative x squared is equal to negative 3/4 times negative 3/4 equals negative 9/16, which is fully reduced because we have no common primes in the numerator and the denominator, right? So is 9/16, right, greater than negative 9/16? Is negative 9/16 greater than negative 3/4? Well, yes, it is, right? This is a smaller absolute value, right, so that it's closer to 0. But since we're on the negative side of the spectrum, it's a negative 1, excuse me. Since we are on the negative side of the spectrum, right, a smaller absolute value means that I'm closer to 0, right? So what does statement 1 really tell us, right? It doesn't actually tell us a whole lot about x itself, right? We have if x is positive, then we know that x is greater than 1, right? If x is negative, then we know x is a negative fraction, right? So these are the two situations that we obtain from statement 1, which alone is not sufficient to answer the question. But as you can see, given statement number 2, where we know that x is a negative number, we know that we are no longer in the positive case in statement 1. We know that we are only in the negative case of statement 1. So when these two are combined, the only case that is possible is that x is a negative fraction, right? Which tells us x is a fraction. X must be a fraction. Right? We don't have to know what that fraction is, but we know that, yes, when we're asked the question, is x a fraction, we can say, yes, it is. Now, so the answer choice is C. Keep in mind that even if we could only say no, it is not, that is still sufficient to answer the question. Only when we don't know, when we cannot say conclusively a response to the question that we're asked, do we choose answer choice C.